Hello and welcome back. Today I want to talk about distribution amplifiers, and I did already several videos about it. How I distribute my 1 megahertz, how I distribute my 10 megahertz, and but I just wanted to be a little bit more precise because you can buy several different distributions amplifiers, and I want to explain the difference. So here we have three boxes that look exactly the same, and I will zoom in. And then we're just going to test them one by one, and I will explain exactly what's the difference. So here we have this is the square wave distribution amplifier. Here is a 10 megahertz frequency standard distribution amplifier. And here we have the STIS5 frequency standard distribution amplifier. And as you can see, they look very, very similar. So what is the exact difference? Well, I'm going to start with the cheapest one or the less expensive one. That is the square wave distribution amplifier. And well, it looks exactly the same as all the other two. I need to test them one by one because also I need them because one I have here. So I need to replace them to show you what I'm going to do. But this is as I said, this is the less expensive one. I think they were around 60 euros, but I think by now they are already around 70. And because of the changes with the European VAT from China to Europe, they are now probably even a little bit more expensive. But still, this is the cheapest model. And well, it's actually pretty does what it says. It's a square wave distribution amplifier. So here you have the input, and the signal that you put in will come out of these 8 outputs. So the idea is when it is for lab reference, you connect it to the GPSDO. So the 10 megahertz from the GPSDO comes in here, and then you have 8 times your 10 megahertz out. And well, let's just do that. I do that also because it is the cheapest. I have one here, I have one there. Okay, so let's connect. Well, the GPSDO here is connected to that amplifier there and also here. So I can just take the signal from here. Let's first see what it looks like. Let me get the BNC in the BNC. Well, we properly terminated on the oscilloscope. And if we have a signal here, here we have our signal. I'll make a screen dump. And you see it is a square wave. It is a little bit of overshoot, but it is okay because you use it for external reference. Let's say for this frequency counter, I can switch it on. This one is connected also. Frequency. Okay, so let me make a screenshot of this. Meanwhile, I get another cable. So you can see it is indeed 10 megahertz. And it is. Okay, print. And as you can see, it is a nice square. So what if we want to have not only one, but 2 times this signal? Well, then we get the distribution amplifier. So what we do then, we take another BNC and we put it in the input. I think I have power here. Yes. It is not that long. Okay. Let me power up the distribution amplifier. Here it is. And from the input to the output. And well, the signal even looks a little bit better. So this distribution amplifier actually works a little bit better than this one. But the frequency is of course exactly the same. Let me make another screen dump of that. So that is perfect. So you can use this for external reference. What we also can do, let me get the signal generator, because that is the nice thing of this one. This one is not specifically made for 10 megahertz. You can use this one also to distribute from DC all the way up to 200 megahertz. And that is a nice thing. So what if I put 1 megahertz? Well, it will just do that. 1 megahertz here, 1 megahertz here, and then it distributes over all 8, and it's just 1, 1, 1. And let me do another print. But we can do the same if we want a lot lower. If we want to distribute 10K, it's also possible. Then we just do 10K. But if we want to do 10 megahertz, what I'm using it for, we can do that too. So that is very nice of this square wave distribution amplifier. It just, what you put in, it comes out. So that's why they also sometimes use them, call them trigger distribution amplifier, because it is great for distributing trigger signals also. If you want to synchronize multiple devices, you can do that with this, because yeah, it can do any frequency. I can even go up to 50 megahertz. You can see it will just go. And then why would you not want to use this for a distribution amplifier? No, I just want to do that, but some people don't, and I will explain you why. Because it is for a wild frequency range. It means that the filtering is not that good. And if you look here, it is a very nice wave. Looks very clean on the spectrum, I mean. But what is the problem? Because it is a square, it is more sensitive also for harmonics. But also just because you can't filter it, because it is used from 0 to 200 megahertz. So what does that look like? If we put this to 100, here is the main signal, and as you see, you also have here the first and the second and the third. Let me print that. Well, are these harmonics a problem? Well, I found out with all my equipment, no. But there are a few people that think it does, and it could impact a little bit. Um, so what if we just look at the harmonics? I will make a screen print also of this. Yeah, the second one, the 20 megahertz, is then at minus 45 dB, so you won't notice that one. But at 30 megahertz, it is minus 10 dB. That one could be noticeable, but usually the equipment is it knows it needs to look around something 10 megahertz, so it's not gonna look for the 30 megahertz. But you can get maybe a little distortion. And if you have really good equipment, maybe even has a band pass filter to to only look at the 10. And I will show you how the band pass looks like. So what you can do is have these little band pass filters. This filter only allows 10 megahertz. So everything below and everything above will be filtered out. And that also will make it look different on the oscilloscope. So let me get this band pass filter here. I need 2 BNCs. So what does it look like on the oscilloscope? There is an actual input and output. So the input I will just put on one of the other channels here. And what does it look like through the filter? Well, you see, because of the resistors and the caps, it is just smoothing in it. But what is the difference on the spectrum analyzer? And as you can see, all the harmonics has disappeared. Let me save that. Let me again do that. Everything is gone. So if you feel a lot more comfortable and you only need to distribute 10 megahertz, then maybe another distribution amplifier would be a lot better for you, because this one does not have the band pass, because it needs to distribute from 0 to 200 megahertz. If you only want to distribute 10, then this distribution amplifier, and it is called the 10 megahertz frequency standard distribution amplifier. This one has on each channel has built in this 10 megahertz bandpass filter. So it means on every output of this distribution amplifier, the signal is just as clean as we have with this bandpass filter. So that is actually a better option, because the cleaner the signal, of course, the better it is. In this distribution amplifier, there are two. You have two options. You have with an OCXO and without. If you use it always on your GPSDO, you don't need the OCXO and you can save up to $10. This one is with, because I want one also with, because if the GPSDO will fail, I'll have another one. But the idea is when it fails, it can run on its own oscillator, and its own oscillator is also pretty precise, and I will show you that. But when you connect something on the input, it will switch off its internal oscillator, and it will start using the signal of the input. Well, it's not really switching it off because it keeps being hot, so I made the switch modification for that. But it doesn't listen anymore to it, and then it will distribute just that. Okay, removed everything. I have here now the 10 megahertz distribution. You saw the alarm is immediately off because now it's running on its internal oscillator. And that is maybe fun to see, because it's probably a fractional off, and especially now when it's heating. And as you see, it is indeed a little bit off because it's still heating. But to show you that it will switch its internal oscillator off, I will put something on the input. And then you see it is using. And now it's exactly 10. But what does it look like? Because we are on the input, we put a square. But we saw with the bandpass filter, it becomes a sine. Do we have the same here? Yes, we have. What does it look like on the spectrum analyzer? Well, exactly the same. Super clean. Well, on the spectrum analyzer, you can see it is again very clean. So it is the same. It is like the other distribution amplifier, but then with the bandpass filter. So why would you not always buy this one? Well, it depends exactly what you need it for, because now I'm inputting 10 megahertz, and that is perfect. But what if we put now 9? Oh, what if we do 9 or 8? And you see that now the signal, it is a lot lower. That is because of the bandpass. It will not pass the lower frequencies, and the same is for the higher frequencies. If you go, because that is exactly what it needs to do. So you can see that this special 10 megahertz distribution amplifier really is a lot cleaner, but you pay more for this because it's already around 90, and I think with the internal oscillator it's already 100, but it is a lot cleaner, but only usable for 10 megahertz. Well, this one was cheaper, and you can use from 0 to 200 megahertz, so that is your choice. And what about the third one? Well, let me get the third one. So I have here the third one, and it's called the FDIS5. And it is, I think it is short for frequency distributor 5 because it does 5 frequencies. So how does that work? This is also with an internal oscillator, but like the 10 megahertz distributor, when you input the 10 megahertz here, it will switch off. It will not listen, it will not switch off. I made this switch so I can switch it off because I never used the internal oscillator. But what does it do? It has two outputs. So when you input 10 megahertz, it outputs 10 megahertz, 10 megahertz. It also outputs 5 and 5 megahertz, and also 1 megahertz and 1 megahertz, 100K and 1 pulse per second. And this is great if you have older equipment. I have here my Marconi that runs on 1 megahertz external reference. You need to think usually when it's 1 megahertz, it is high impedance, like 1 mega ohm or something. So you need to put also their terminator resistor on your BNC. And I have there also an older Nixie frequency counter from Marconi. That one also runs on 1 megahertz. So that's why I needed this one. But some older HP equipment, I think also runs on 1 or 2 or 5 and something. So that's why you need that. This one is like the 10 megahertz. I think it also has these band pass filters on each output, but then for the corresponding frequency. So that is what I'm trying to do. I will connect it. We see how clean is the signal and if the filtering is good, because I'm also interested in that, because from this one I don't know. So let's have a look. We switch it on. Well, there will be an alarm because the oscillator is not running. Now it is, but we're not gonna use the internal oscillator. We're gonna use 10 megahertz input. And yeah, you could say it is a bit of expensive to use this device if you just want 1 megahertz for your Marconi, because you can easily make a little prescaler or divide by 10. But I like also it has the filtering, and for me this was also a backup for the GPSDO when I only had one. So that's why I did it like that. So first we can have a look at the 10 megahertz. Looks very sweet. What does the spectrum analyzer think? It also thinks it's very clean. Okay, so that looks very clean. How about the 5? Is ook goed. Also very good. What does the spectrum analyzer think? I also see only one. We can put the maximum frequency a little bit lower, like 50, so it will be a little bit more easy to see. And I will also do a print. So what if we put 1? Well, the 1, then I need to go a little bit lower here. I will just set it to 0. And it is a little bit harder to see. Save. But no harmonics. So this one also has perfect filtering. Good to know. So that was a little bit fast and a little bit messy, but a little roundup. The cheapest one is the square wave distribution amplifier or trigger signal distribution amplifier. And this is perfect if you need the frequency other than 10 megahertz. And you can do from 0 up to 200 megahertz. If you want a clean signal and you use it for external reference 10 megahertz only, Then you use the 10 megahertz distribution amplifiers, a little bit more expensive, but all your harmonics are filtered out. Very good. If you have older equipment like HP or like me, the Marconi, you sometimes also need 1 megahertz or some equipment even 5. And then you can use the FDIS5. The FDIS5 also has 10 megahertz input, so you can connect it to your GPSDO, and then it can output 10, 5, or 1 megahertz. So that is perfect. Also with filtering, so also all your harmonics are really, really, really low. If you want to know a little bit more on GPSDO, I made several videos about that. And if you look at my latest, I explain how you can, if you have this type from BG7TBL, if you have one of these, if you have GPS only, or you have GPS in Galileo, or only GPS in GLONASS, I explain that exactly how you can switch on any system you like. So this one was GPS only, and now it is doing Galileo and GLONASS and GPS, and even S-Bus D GPS I switch on, and it is just for free. Just watch my video. It was maybe a bit fast. If you have questions, just leave it in the comments. I always try to answer them. I will also put the items in my description. I buy a lot at AliExpress, and I have some experience which seller is good and which one is not. So it's not always the cheapest, but it arrives pretty nice. So important to know, I think. Have a look at those links. That is it. Thank you for watching, and I hope to see you next time.